Hi, welcome to my video on extra area problems. To start off the extra problems, as I mentioned before, we should memorize the formulas for the parameters of geometric figures, the areas of geometric figures. If we know them, then it's easy to recall. Let's see if we can match them up. Pause. Practice means pause the video to see if you can get these matched up with the formulas, with the names. Match the area formulas with the name. A parallelogram. A parallelogram is base times height, so number 7. A circle is pi r squared, number 6. A triangle is half the base times the height, number 5. A rectangle is length times width, number 4. A sector of a circle is a part of a circle, so it's 8, the central angle over 360 times pi r squared. A square is a rectangle, but the sides are equal, so it could be length times width, or a, s squared. A trapezoid is a, half the height with 2 bases, so it's number 2. Notice the trapezoid as this diagram, base 1, base 2, and the height is perpendicular to the base. And a semicircle is half a circle, so it's a 3, half of pi r squared. A circle is number 6, pi r squared, so a semicircle is half a circle. And a rhombus is the same as a parallelogram, and it should be base times height. Same as a rhombus and a parallelogram, same formula. So that's just a little review of the formulas. You should memorize them. Make sure you should be able to, write them down as soon as it's said. Now, practice means pause the video, work this question out, and play it back to see if you have the right answer. And do that for each one of these questions to see if you understand what's going on and you can work it. Find the area of this figure. Now, there's many ways to find the area of this figure. One way would be, I could, if I want, mark this dot line down here, and mark this. So I can get the lengths of each of these sides here, and I can do a subtraction. So I could do the big area, which is 15 by 10, subtract this small area, and that will give me the answer. That's one way, so let's try it. So if this length up here is 15, and it's 15 from here to here, that means that this must be a 7 inches, because 8 and 15 makes, 8 and 7 makes 15. And this length here, if this side over here is 10, and opposite sides are equal, and that means that this is a 4, so 6 and 4 makes 10. So we have the large area, which is, I can say the area, I'm going to say L for large, which is length times width, so that's 15 times 10. So the large area is 150 square inches. And the small area, I'm going to say S for small, is length times width. Again, it's a rectangle. This is meant to be a rectangular shape, all right angles in all the corners. Just sometimes this is understood. And length is 7. The width is 4, so that's a 28. So the area is the area of the large, subtract the area of the small, so that's 150 minus the 28, so that's 122, and we have inches squared. Remember, that's inches squared too, is area, so that's one way. There is another way to do this, and let me draw the diagram up here higher so I can use it. So let's redraw this diagram, not exactly as is. So we have a 10, a 15, a 6, and an 8. Another way to do this would be to mark off separate the figure into 2 different rectangles. Remember, these are rectangles. So if I make 2 rectangles, then I have this rectangle here is 15 and 6, length and width. So what I need this one is, that's an 8. I need this. So that's 6 and that's 10. So that means the length of this side is 4. That's the same length I found right there is 4. So now I got 2 areas I can add. So the area of the large one, A, area of the large L, in this case, is LW. So it's 15 times 6. That makes it 90. And again, it's square inches, because it's area. The small area, is marked S, is length times width, because it's a rectangle. So it's 8 times 4. So that's 32. And we're adding them up. So the area of the figure is, we could say the area is the large one plus the area of the small one. And that gives me a 90 plus a 32, which adds up to be 122. So notice here I did the large subtract the small, and here I did adding the 2. Also, but you can work this one out if you think about it, I can also split the diagram into these 2. So this one and this one. So if this is 10, and that's a 6, and that's an 8, and that's a 15, if I split it this way, again, this is a 7, same as up here, 7 right there. So this area is 42, and this one right here is a 10 by 8, so that's an 80. So if we take the 80 and add on to 42, we get a 122. So I didn't work all that one out. I just showed you that you can split it into 3 different ways to find the answer. So notice. Number 2, find the area of this figure. So we have looks like a triangular shape or part of a rectangle. And we got, so if that's 8, then that's also 8. Since these are 2 right angles here, this height is the same, 8 and 8. So that means if I join this up going through right here, I've made a rectangle, because these are going to be right angles now. And that means that that's a 12. So in dealing with the math, what you have is, if you take this diagram, because that's a 10 and a 10 with a base of 12, and these 2 sides are equal, I can drop a perpendicular from the apex angle in this isosceles triangle, drop a perpendicular down to the base. And because these 2 sides are congruent, this perpendicular splits the base into 2 equal parts. In other words, it forms 2 congruent triangles. When we do congruent triangles in the videos, you'll see that these triangles are congruent, but what they call HL, hypotenuse leg. But it splits the base, and that means, because it splits the base, I got a c squared equals a squared plus b squared, Pythagorean. That means that this perpendicular, which I'm doing over here, as well as in this diagram, that gives me the height of the triangle. So if that's the height of the triangle down here, which is also right here, I have C is the hypotenuse in the right triangle, that's 10. If you let A be the height and B be the base, B be the other side, so you got 10 is the hypotenuse of C, so H and 6 can go anywhere. So that's 100, 10 squared, H squared, 6 squared is 36. So H squared is 100 minus 36. So H squared is 64. So H is equal to the square root of 64. So the height is 8. So the height of this triangle is 8. That means I can find the area of both of these. So I can find the area of the rectangle. I'm going to call it R, length times width. So the rectangle is a 12 by 8. So 12 eighths is 96, and it's square meters. I can also get the area of the triangle. I'm going to call it T, half base times height. The base of the triangle is 12, and the height we found it here to be 8. So half of 12 is 6, and 6/8 makes 48. So the area of this figure is the total, I'm going to call it total area, A, is the area of the rectangle plus the area of the triangle. So that makes it 96 plus 48. And if you add that up, you get 144. And it's, again, areas in square meters. We added these up, we got square meters. So, knowing the formulas, working them out, take your time. Pythagorean, very, very important property. Let's move on. Number 3. We have as you can see, 3 circles. I call these concentric circles. Circles that all have the same, no, sorry, they're not concentric circles. Concentric circles have the same centers. These don't have the same centers. So this is a rectangle. PQRS is a rectangle. And all the circles have equal radii, so the radius of all of them are the same. Find the area to the nearest tenth of the shaded region. Well, if the width of this rectangle is 8.2, that means that the diameter of the circle is 8.2. So if the width of the rectangle is 8.2, that means your diameter of your circle is 8.2. That means your radius is 4.1 and is in feet. So the radius of the circle. So if this is 8.4, that's an 8.4 there, an 8.4 there, and an 8.4 there. That means the total width, the total length of your rectangle is 3 times 8.4, which is, if you multiply that, you get 24.6, and again it's in feet. So we have a rectangle, which is a length times a width. The rectangle is 24.6 times its width, which is 8.2. And when you multiply that out, you'll get 201.72. And we want to round to the nearest tenth, so sometimes some teachers will say, don't round yet, round at the end. Because if you round too early, you could throw your the answer off by a tenth. So let's round at the end. Now we have the diameter of the circle, we have the radius of the circle, so we need to get the area of one circle. So the area of, let's do that for a circle, is pi r squared, so it's 3.14 times the radius of the circle. We worked it out to be 4.1 squared. So if we take a calculator and go 3.14 times 4.1 squared, or 4.1 times 4.1, you'll work that out to be the area of the circle is 52.7834 roughly, and that's in square feet. So make sure feet squared. This area is in square feet. And we have 3 circles, so it's 3 times 52.7834. And that works out to be 158.35. You got to use your calculator just to make sure that these are all working right. To multiply this by pencil takes time, so calculator. Now we have the area of the rectangle, 201. We have the area of the triangle, 158. But to get the shaded area, all right, shaded area is the area of the rectangle, let's call it R, minus the area of the circles. So we have a 201.72, subtract 158.3502. And when you subtract that with a calculator, you'll get 43.3698. And we says round to the nearest tenth, so it's 43 tenths is right here. So all these numbers, digits, become 0. And because that's greater than 5, we add 1 to 3. So the answer is 43.4, and it's in feet. So the final answer is 43.4 square feet. And number 4, a square has an area of 16 square centimeters. Find the length of its diagonal to the nearest tenth. Well, if you think about it, we have a square. So let's make a square. A square has all sides equal, so it's S, 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 S. The area of the square is, we know, is length times width, which is S squared. So the area of the square is 16, so 16 equals S squared. So S is the square root of 16, so the length of the side is 4. And so if we redraw this diagram with the 4 in there, so we got a 4 and a 4 and a 4 and a 4. The diagonal, I can draw this diagonal right here, or I can draw this one. It makes no difference. So if I draw this diagonal, diagonal goes from one corner to the other, not being a side. And this is a right angle, so that means we can use our Pythagorean. So I'll call the length of the diagonal D for diagonal. So we got C squared is A squared plus B squared. And in this Pythagorean, C is the hypotenuse opposite the right angle. So D is opposite, D is the C in this diagram, opposite the right angle. So A and B are 4 each. So D squared is 4 squared 16, 4 squared 16, 4 times 4. D squared is 32. D is equal to the square root of 32. And when we work that out with a calculator, square root of 32 is 5.656. And we want the answer to the nearest tenth. So the answer is, again, there's tenths right here. So these two become zeros. And 5 or greater, add 1 to the 6. So it's 5.7, and it's in centimeters because it's just a length. So the length of the diagonal is 5.7 centimeters. Okay, let's continue. More practice. And you know what practice means. Pause the video, work out the answers. Let's see what we have here. We have a circle. It says O is the center. It says OC is parallel to AB. OC is parallel to this. These two lines are parallel to each other. And with parallel lines, we have angles equal. So let's see why that's given. It says OC is 4. So OC is 4. Okay. And it says angle, the measure of angle OCB is 65. OCB. So this angle is 65 degrees. Now, we want to find the area of the shaded region. Now, shaded region looks like it's a sector. It's a 2 radii and an arc, so there's a sector in here. A, O, B, this area is a sector. So we're finding the area of the shaded region. We're finding the area of the sector. Well, let's see what we have. We have that side equals that. Equals that. All of the OC, OB, OA are all equal because they're radii. And what happens when we have two in a triangle, two sides equal? Then we have two angles equal. So if this angle is 65, this angle is 65. Because the angles opposite the equal sides are equal. So that makes 130. So 180 minus 130 gives us 50 degrees. So that means this angle right here, COB, is 50. They add up to 180. Now, why is the parallel lines given? Well, parallel lines have corresponding alternate interior angles, alternate exterior angles, etc. So, if this angle is 50, that means this angle right here is 50. This angle is 50. Alternate interior angles, Z, forms a Z with the transversal. And because these two sides are equal, that means the base angles are equal. So this angle is also 50. Same as we have here. Two sides equal, two angles equal. So these two angles are equal, 50-50. That means that we have 180 minus 100. So that gives us this angle right here 80 degrees. There's 80 degrees right there. And 50 and 50 is 100, plus 80 is 180 is a check. Now we want the area of the sector. So the area of the shaded region is the area of the sector. The area of the sector is the central angle over 360 times pi r squared, because the central angle is a fraction of the circle, so it's a fraction of the area. And the central angle is 80 over 360 and 3.14, and the radius is 4, so it's a 4 squared. Now you can reduce this down, or you can just, if you want, you can take 80 divided by 360 times it by 3.14 and times it by 4 squared, or 16. Or we can reduce it down 0. 4 into 8 goes 2. 4 into 36 goes 9. So we can have 2/9 the same as 80 over 360. So 2/9 times 3.14 times 4 squared gives me 11.164, etc. And that rounded off is 11, and it's to the nearest hundredth this time. So this is the hundredth place right here. So all the digits to the right become 0. So this number is less than 5, so we do not add anything on to the 6. So it's 11.6. And it's in centimeters, so it's centimeters squared because it's area. So there's the final answer. And how did you make it? Hopefully, I keep reviewing all the skills necessary to move on to the next math courses. If you keep reviewing them, you recall them much easier. Number 6, let's work this one out. 2 people bought the same type of tiles from 2 different companies. Person A paid $1,050 for a 10 by 7 floor. Person B paid $756 for a 9 by 6 floor. When you say the 9, we mean these are rectangular floors. Which person paid the better unit price? Well, to get that, let's look at person A first. So the area of the floor that, notice he paid this much money, who had the better unit price, and we're talking about he paid in square meters. So person A, the area is length times width, so it's a 10 times 7, so that's 70 square meters. And person A paid $1,050. So the unit price, I'm going to say unit price, is 1,050 divided by his area. So notice this is dollars divided by meters. So when you divide that with a calculator, you'll get $15 per meter. That's a unit for 1 square meter, square meter, because we did the area. So person B, we have the area of the floor for person B, so we got length times width, we got 9 times 6, which is 54 square meters. And person B paid $756. So the unit price per square meter is 756 divided by 54. And that's dollars, and that's square meters. So when you divide that, you get $14 per square meter. Again, the square meters there. So 756 divided by 54 is 14. Notice person A paid $15 a square meter. Person B paid $14 a square meter. So the better unit price, the less you pay per square meter. So person B is better by $1 per square meter less. Again, that's $14. So the better price is the less dollars you pay per square meter. So person B got the better deal for the same type of tiles. And another one, practice. Practice means pause the video and work this out. Here we go. The circumference of a circle is 62.8 centimeters. Find the area of the circle. Well, let's see. When you got, it says circumference, the circumference is 2 pi r. And it says area of the circle, so the area of the circle is pi r squared. So if I'm given the circumference, if I want this to think about it, if I want the area, I need the radius. So they gave me circumference, so let's plug the circumference in 62.8. 2 times 3.14 times r. Multiply 6.28 r is 62.8. And if you divide by 6.28 on each side, 6.28 cancels out, I get r, and 62.8 divided by 6.28 is 10. So the radius of the circle is 10. So you go over and plug in the area formula, 3.14 and 10 squared. Well, 10 squared is easy. That's 100. 10 times 10. And when we multiply by 100, we move the decimal 2 places to the right. So the area of the circle is approximately, is not exactly, because 3.14 is an approximation. So the area is 340 square centimeters. Number 8. Notice we have something like this is an archway, like a part, looks like a semicircle, and we have a diagram. So it says that A, B, C, D, E. This is a window. Is a window, and we want to. It says DC is 10, so that's 10 right there. The area of A, B, C, D is 80. This is CD is equal to AB, so that's CD is 10, AB is 10 also, because it says they're equal. It says find the area of the window to the nearest tenth of a square meter. Well, again, we have, looks like we have two right angles. These are both the same height, so we drop a line or put a dotted line across there. That means that these two heights are the same with these right angles, so these perpendicular distances are the same. So whatever we have here, whatever this length is, this length will be the same. So it says, if you read, the area of the rectangle, ABCD is a rectangle when I join this. So the area of a rectangle is length times width. We have the length, the area is 80, and the length is 10. So what's the width? So if you divide by 10, we can see the width is 8. So 10, and this is 8. And you could say, well, how do you know that 10 was the length, not the width? Well, it makes no difference. If you put the 10 in the place of the width and worked out the length to be 8, then you say, oh, so there's 8 and 10. But, you know, again, now I know 10 is the length. But it didn't make any difference if you put 10 or 8 in either one of these. It works. The other one works out to be 8, so therefore you say, oh, I got 8 and 10. So that means that's 8. And I can get the area. I have the area of the rectangle. I need to get the area of what we call this semicircle, half a circle. So the width of the rectangle, which is 8, also happens to be the diameter of my semicircle. Remember, this is a semicircle. If I just do this, you'll see that this is the circle. So this is half the circle. So I have a diameter of 8. That means my radius of the circle is 4. And since I have a semicircle, so the area, I'm going to call it SEMI, semicircle, is a half the area of a circle. So it's a half times 3.14, and my diameter is 8, my radius is 4, so it's 4 squared. And if you want to multiply all that out, now some people, some students or teachers find the area and then take a half of it after. I have a tendency to put the half into the formula right away and work it out. It's either or. So a half is 1 divided by 2, or 0.5, times 3.14 times 4 squared, which is 16. And that works out to be 25.12. Not going to round it, and it's in feet, so that's square feet, feet squared. So what's the area of the rectangle? It says the area of the rectangle, so the total area, total A, is the area of the rectangle plus the area of the semicircle. So the area of the rectangle was given to us as 80, and the semicircle is 25.12. We add that up, we get 105.12. Now, if I round it at the end, like right here, then I'm going to be more accurate. If I round it here, not that this problem will be wrong if I rounded this off to the 10th, but in most cases, if you round at the end, you're more accurate. So the area, I want to round it to the nearest tenth, so that's 105. So tenths, so that's 2 is less than 5, so I do not change to 1. So the area is 105.1 square, or feet squared, or square feet, makes no difference. Again, you have a semicircle here, a window with a semicircle, half a circle, and a rectangle. Let's continue. Another problem. Plenty of problems to work out using your math. Here we have what looks like a circle touching right here on all top and bottom. And we have a trapezoid, which is 2 parallel sides. And we have a length of 7. This length is 10. This is a 5 coming down here. And we have 2 right angles. How do I work out? This is find the area of the shaded region to the nearest hundredth. I got to find the area to shade it. So the trapezoid is the large figure. The area of the circle is inside. So if I subtract the two of them, I will get the shaded. But how do I get the area of a trapezoid? The area of a trapezoid is half the base, half the height, base 1, base 2. I have the 2 bases. Let's see. The area of a trapezoid is a half the height, base 1 plus base 2. Okay. I have base 1. Base 1 is 7. Base 2 is the other bottom is 10. But I don't have my height. I can't fill the height in. So I got to go and work out the height. Let's see. Perpendicular. These are 2 parallel lines. This is the perpendicular distance right here. So this perpendicular distance between these 2 parallel lines, if I drop a perpendicular from this point down to here and make that a right angle, perpendicular from here right on down, now I have a right angle here, here, and here. So that means I have a right angle here. That means this figure is a rectangle. That means that this height, perpendicular here, is this same right here, because these 2 heights are equal. So this is the, and that's a 7. That's a 7. So 7, 7, height, height. So if that's a 7, then this little piece right here must be 10 minus 7. So that must be a 3, because 7, opposite sides are equal, 7 and 7. 7 and 3 makes 10. So now I have a right triangle. Oh, a right triangle, Pythagorean. C squared is A squared plus B squared. The hypotenuse is opposite the right angle, so that's a 5. H is A and B is 3. Makes no difference, which is, as long as C, which is opposite the right angle, I always fill in the C first, and the side opposite the right angle is the hypotenuse. 25, 9, 25 minus 9, H squared is 16, h is the square root of 16, h is 4. So, by working out Pythagorean, now I can go over here and fill in my height of 4. Because I have a rectangle, the lengths are 7 and 7, so the height is 4. These heights are the same. That gives me and I'm going to do bed mass. I'm going to add first, because I always do inside the brackets first. Now I multiply. Half of 4 is 2. 2 times 17 is 34. Okay. Now I need the area of the circle. So the area of a circle is, let's see, I have a height. There's the height. So if the height is 8, that means your diameter of the circle is 8. That means your radius is 4. So that's 8 from there to there. So there's a 4 and a 4. And there's a 4 here and a 4 here. So the radius is 4. So the area of a circle is pi r squared. So it's 3.14 times 4 squared. And 3.14 times 16 gives me 3.14 times 16, and what do we get? 12.56. If you don't round it yet, round it after, and you'll be more accurate. Now, the area, the shaded area, is the area of the trapezoid minus the 12.56. And when you do that, you get 21.44. Now we can round it. So it's 21.4, and it's centimeters squared. So it's the difference of the two. Then you round it at the end. Remember, there's the tenths place. So the number to the right is less than 5, so we do not change. This is 4, so it's 21.4. Completed. Good bit of math here. Always thinking. The more math you do, the more thinking you do, the better. Geometry does that to people. A rectangle and a triangle have equal areas in number 10. The width of the rectangle is 10. The base of the triangle is 4 times the width of the rectangle. The height of the triangle is 150 times the width of the rectangle. Find the length of the rectangle. Holy mackerel, what have we got going on here? Let's have a look. It says they're equal in area. That's important. So the area of the rectangle is equal to the area of the triangle. Okay, keep that in mind. Then it says the width of the rectangle. So the width of the rectangle is 10. Okay. It says the base of the triangle is 4 times the width of the rectangle. So the base of your triangle is 4 times the width. So that means it's 4 times 10. So the base of your triangle is 40. Okay, we got the base of the triangle. We need the length of the rectangle. So this is the width of the rectangle. We need the length. So let's continue. Let's read on. The height of the triangle is 150 times the width of the rectangle. So the height of the triangle is 150% the width of the rectangle. So it's 150% of W. So it's 150% times the width. And the width is 10. So that means that 150% is moving decimal 2 places to the left. So 1.5 times 10. So that's 15. And it's 15 feet. When the base is in feet, the width is in feet, the height is in feet, everything is in feet. The area is in square feet. And it says the area of the triangle equals the area of the rectangle. So the area of the triangle is half the base times the height. And the base is 40. The height is 15. Half 40 is 20. 20 times 15 gives me 300. So I have the area of the triangle and it's in square feet. But it says the area of the triangle is equal to the area of the rectangle. So that means the area of the rectangle, which is length times width. The area is the same, so it's 300. The length we're looking for, the width is 10. And so we divide by 10 on each side. So the length is 30. So again, I like to twist things around, make you think more. So you have to read each of these as going on. So you needed the length of the rectangle. So therefore you need what? If you needed the length and you had the width, you need the area. So to get the length, you had to get the area. And everything worked out. So I put in some extra wording because this is what the algebra will do, this extra wording. Helps you think. You think it through. And the last question. Practice means pause the video and work it out. Let's see. Two circles are concentric. Oh, concentric. Concentric circles, they have the same centers. So these two circles have the same center O. And it says OA is 3. And it says OB is 4.5. So OB is 4.5. 4.5, 2 radii. Find the area of the shaded region. So the area of the shaded region is the area of the large circle. And we're going to get the area of the small circle. And then shaded is the difference. So the large circle is pi r squared. So it's 3.14 times 4.5 squared. And 3.14 times 4.5 squared with a calculator, 63.585. And again, leave it till the end to subtract. The small circle is pi r squared. And the radius of the small circle is 3. So it's 3 squared. So 3.14 times 3 squared gives you 28.26. Again, leave it like that until the end. So the shaded area is the area of the large minus the area of the small. And so that's 63.585 minus 28.26. When you subtract the two of these with your calculator, you get 35.325. And we want to round that to the nearest tenth, it says. So let's see, tenths. So they become 2 zeros. This number is less than 5, so 3 stays as it is. So it's 35.3. And it's in centimeters, so it's square centimeters. Remember, this is centimeters squared. This is centimeters squared because it's area. So the final answer is 35.3 square centimeters. So that's a review of your area of different figures. And if you like my video, click the like button. If you're not a subscriber, click the subscribe button. And if you are a subscriber, click the notification bell because there's more videos coming, more topics, more units. Write a comment on my video if you wish. And visit my math website, www.mathfullyexplained.com, to find information on me, my videos, teaching strategies I'm going to use to help you learn, and the content that's on my YouTube channel. I'd like to thank you very much. Bye-bye.